Hello class, so today we're going to be working on fractions, specifically using egg cartons, or in this case, something that is similar to an egg carton, which is this 12 block diagram. So there are 12 eggs in a carton, correct? So of course we're going to have 12 boxes in our diagram. So the problem I chose to work on today with you guys is number 6. Which is 2/6, 2/6. How do you guys think we would display this on our egg carton diagram? So I think a really good way of doing this is using post-it notes. So over here you can see that we have some post-it notes. So 2/6, of course, there are 12 boxes in this diagram, correct? So we know that 6 is half of 12. So 1, 2, 3, 4, 5, 6. So there are 6 boxes on this bottom row. And this is saying we have 6 total over here. And as we stated before, there are 2 6s in 12, right? Because 6 and another 6 equals 12. So if it's asking for 2/6, this is 6, which would be shaded in 2 boxes, right? So this box and this box would be shaded in if we were discussing 2/6. But since this egg carton has 12 instead of 6, what would we do? So remember, 6 is half of 12. 6 plus 6 equals 12. So this box and this box would also be shaded in, as that accounts for 12 instead of just 6 boxes. So that would be 4 boxes shaded in and 8 boxes remaining. Does that make sense for everyone? So if we were to work on this second problem, 3/3, of course, we already determined that this whole thing is 12, right? And as we said, 6 is half of 12. Does 3 go into 12? Right, so 3 goes into 12 how many times? 4 times, right? So if we look at this diagram, another way to do this is we see 3 boxes right here, right? So that's one group. 3 boxes right here, that's another group. 3 boxes right here, that's another group. And 3 boxes right here, that's another group. So there are 4 groups. So if all 3 out of 3 are shaded, what would that represent in this diagram of 12? So we said that 3 goes into 12 4 times. And there's 4 groups of 3, and it's saying 3 out of 3, which we know equals 1, a whole. Wouldn't that mean every single box is shaded? Yeah, every single box is shaded. After the class has solved both of these problems with me, then I would have them work on their own problem. So I use number 12 as an example, 11/12. So I'd have them fill this in. So since there's 12 boxes, they have to figure out how many to shade in 11/12. And I would pop around the room and see if every kid has an understanding, and if they don't, I will work with them quietly as the group continues working on other problems. Then I would love to introduce a little combination. So we still have the diagram of 12, but I want to see if my students are able to do 2 fractions sum as the shaded squares. So in this case, I chose 1/6 plus 1/12. And as the students and I discussed in the first problem, 6 is half of 12, so they will be able to solve the problem to their best ability. After they'd solve it, then I'd go over it with them just in case to make sure everyone understood, so we know that 6 is half of 12, right? So we can do times 2, which of course we have to do times 2 up there as well. So it would be 2 over 12 plus 1 over 12, which of course is 3 over 12. And then we'd discuss how many boxes to fill in, and I would let them work on that with me and raise their hands to answer the question, and we would then get to 3 boxes shaded out of 12. But yeah, I would just make sure each kid understood and going around the room, because I know math can be a really hard subject for a lot of kids, and I just want to be there and help support them.